Welcome to part 2 for the Unit 3 review. Should get those numbers right. Okay, so here we're starting on number 15. Everything prior to this, if you're looking for those, that would be on the Unit 3 part 1 test or review, not here. So this is for the part 2. So here, Terrence receives his gift card for $80 from his friend for his birthday. So he can pay for an online subscription, whatever it may be, right? That is $8 a month. Write a function that describes the dollar amount of the money, D, on the gift card after T months. So apparently I cannot read very well, but we'll work on that. So we want to write this function. So let's take a look here. So we know that we have this balance here, right? We're starting with the $80, and then it was slowly going to go down, right? It's going to go down $8 every month. We're assuming that he's not using it for anything else. He's just $8 a month. Right? How long is that going to last him? A lot of you guys did it already. You had like 10 months. Right? So we want to write that as a function. So here we go. So the amount of money, which is D, and it's a function of T. So D of T is equal to, I suppose I should write this down here. Let's start again. So D of T is equal to, because it says function. So technically we should write in function notation, right? And then what are we taking away every single time? This right here. So we're taking away $8 every time, right? So this is our slope. So, and we're going to multiply that by X. And then what do we start with initially? The $80. So this is our y-intercept. Okay, our y-intercept, which is our initial amount. Okay, and I say B for the beginning amount, right? This kind of works. All right, so there's a function. It says graph the function that you wrote in part A. So label the X and Y intercepts and explain what they mean in context. So a couple of different things going on here. So we're going to first figure out, okay, so I'm not going to go very far on this. So I was like, it's 1, 2, 3, 4. You have to do all of them. I suppose I could have skip counted, but we're just, I already started this. Okay, so this is number of months. You know, technically it's the number of months since you received the gift card, or he or she received the, I forgot who it was. And then here on the y-axis, that's going to be amount, or I guess the balance on gift card. And we measure that in dollars. All right, let's see if I made this. So we want to go all the way up to 80. So this is probably going up by tens. So we'll go, this is 80, 70, 60, 50, 40, 30, 20, 21. There we go, 10, just like that. I guess I'll just continue this up. And so we know at 80, so we're going to start at 80, point right there. And our slope says down 8 over 1, right? Kind of hard for me to tell. So what I'm going to do is I'm going to kind of like, okay, so down 8, so that would be like 72 over 1. So like right about there. And then 72 minus 8, 63, 64, yikes, 64, so close. So do you see how it's kind of hard to graph on there? So what I'm going to do is I'm going to think, okay, well, if I go down, I know after 10 months, I should have nothing there. I'm just going to go like this. I got my 2 points, going to draw that line, right? So that's my cheat way to do it, because I can just do that in my head. So I can do this straight line. You do as straight of a line as you can. Okay, that's not supposed to be crooked. So a straight line just like that. And if you have your ruler, use that, or just do as straight as you can. And then it says label the X and Y intercepts. We kind of already did that. We have, so this is our Y intercept, because that's where it crosses the Y axis. So Y intercept, which is 0, 80. And what does that mean? So that means, what does it mean? When we've, it's 0 months. So when, who is this? When Terrence, forgot it was Terrence. So when Terrence receives the gift card, so he didn't even use it yet, it had a balance of $80, right? And the answers in the back or in the bottom, if you scroll down to the bottom, it may have a slightly differently worded answer. That's as long as it conveys at the beginning, you know, when Terrence first received this at time 0, right? At the beginning, the card had a balance of $80. That's what you need to say. And then what does the the x-intercept mean? So this part right here, this is the x-intercept, which we know to be 10, 0. So what does that mean? So after 10 months, right? Because the 10 refers to the number of months. After 10 months, the gift card will have a balance of what? Of $0. So sad. Gotta go pay for it himself now or cancel the subscription. Either one, right? So that's how that's gonna go, all right? I don't know if I go through this. Okay, so this is the only one. There's only one problem of this type in this packet. Sorry, this is all I can do. There will be one problem that's like this. Do as best as you can. I would go over this. What I would personally do is I would try and do this by myself and then compare again. Even though you're like, well, we already just did the problem. Well, it's different when you actually try to do it yourself. So if you have not done that already, make sure you pause, do it yourself, and then go back and check. Okay, that's the best way for your brain to learn. All right, okay, I don't know about the best way, but a really good way. All right, so we're gonna go into the next one. So number 16, use the function f of x and g of x to complete the comparison statements using the following words: less than, greater than, or equal to. So the slope of f of x, so where's f of x? Right here, here's f of x. So we're gonna have to figure out that slope. And we're comparing two things, or g of x, this right here is g of x. So which one has a bigger slope? That's what we're gonna compare. So I'm looking at, okay, these have like these 0.5. So what I'm gonna do is I'm gonna look at 4 and 7. So between 4 and 7, what was that difference? Well, it's like me adding 3, right? And between 4 and 6, that's like me adding 2. Now we're not checking to see if these are linear, not linear, or else I would check all of them, but we're already given that it's a linear function. So I don't have to check all of them. I just want to figure out the slope. So I can pick any 2 points and find the difference of them and find out the slope. So my slope here is going to be 3 over 2. Remember, it's the change of y over the change of x. So let's see what this one is. So I'm going to pick 2 points here. So this one, it looks like a nice point there. This one looks like a nice point there, right? Honestly, I could pick any of these points right here, right? But I'm going to pick the ones that are close together. If you pick ones that are far apart, then that just means that you're going to have to simplify it. And I don't really want to do that right now. So I'm going to go up. How much do I go up? That's going to be 2. So that's going plus 2. And I'm going to the right 1. I'm only going over 1. So this is going to be, again, the y. The y is the up and down, right? So the y, so it's 2 over 1, which is going to be just m is equal to 2. So which one is bigger, 3/2 or 2? 2. So which one is bigger? It's going to be g. So it is going to be f of x is less than g of x, right? Okay, so then here we go. So the y-intercept, if we're looking at the y-intercept, we don't have the y, but we can figure it out, right? So we know if we go every 2, we go down, we're going to add 3. So if we're going the reverse way, every 2 we go back. So I'm going to go 2 back. So this would be 2. So I would subtract 2 because I'm going back. I'm reversing this cycle here, right? So then I'm actually going to undo so that's going to be minus 3. So this is going to be 4 minus 3, which is 1. All right, so far so good. And then if I go back another 2, I'm going to hit 0, right? So I go back another 2. Oh, I'm sorry, does that confuse you? If it does, I'm sorry. But if it didn't, then that's okay. That's how I like to think of it. So remember that this difference, it has to be +2, right? So it's something +2 is going to give me a 4. Well, that better be 2, right? Because 2 + 2 is 4. So same thing with this one. This something +2 is going to give me a 2. So what would that be? What was that previous number then? It would have to be 0, right? 0 + 2 is equal to 2. All right, same thing here. So between 1 and 4, 1 + 3 is 4. So, we have to keep those same numbers. So if you look right here, what would this number have to be? So we know that between them, it has to be 3. So something +3 is equal to 1. So let me see, something +3 is equal to 1. Well, then this is probably a negative number, right? So if you think about it, it has to be -2 + 3 is equal to 1. If you don't remember that, I just like to look at a number line. In my brain, I visualize a number line. Here's my 1. I just know that 3. So from here to here, this is 3. So I added 3 here, right? So what would this number have to be? I'm like, okay, well, here's 0. Then that's 2 more spaces. So that has to be -2. That's how I like to think of it. All right, so that is -2. So now that we know that, the reason why, what is the whole reason for this? Because we wanted to find out what our y-intercept was. And the only way we could find our y-intercept is when x is equal to 0, right? Because if we were to plot this, right? If we were to plot this, let's just borrow this graph right here. 0, -2. Where's 0, -2? 0, -2 right here. See that? Okay, so this is where that y-intercept is. This is the y-intercept of f of x. Well, where's the g of x's y-intercept? Oh, it's all the way up here. Do you see how it's right here? This is the y-intercept. Oh, I should probably use a different color. So we'll go pink. So this is the y-intercept of g of x. Well, which one's bigger or which one's greater? Well, the one right here. So g of x is definitely bigger. So again here, y-intercept of f of x is less than, happens to be less than g of x. All right, and if it was flip-flop, then we would say greater than, that kind of thing. So that's how you determine that. That's the end of that one. All right, we're going to go into the next one. It says evaluate these functions, and it says do not round. So don't round. So this is what you would do. Well, okay, you're like, decimal points. You're like, Miss Lee, really? I'm like, yeah, really. It's actually not that hard, I promise, right? So remember this f of x. This is referring back to this function right here. That's why we say f of x. So this f of x is that f of x, but instead of this x, we have a 2.4. So what are we going to do? We're going to replace anywhere you see the x, we're going to replace it with 2.4. So we're going to go 1.23 times 2.4 minus 3.72. Okay, so you notice everything else is the same except here. So anywhere you see this x, do you see this 2.4? That's where that's going to be. So we're not saying f times 2.4. This is just the function of 2.4. So when x is equal to 2.4, what is y equal to? Well, and you're like, well, I got to make some calculations. So that's what you have to do. So this one, I'm not expecting you to do this by memory or like by hand. That's too hard. So if you have Desmos or if you have a calculator, please use that. And so I'm going to just put that into my calculator. Let's see. Where's my calculator? Okay, so here's a calculator. I'm going to just clear this up for a different class here. So I'm going to be, okay, so 1.23. We're going to, where's my mouse? Multiply that by 2.4. And then add, oh no, just kidding, not add. Go back. We're going to subtract 3.72. And that's going to be negative 0.768. And it says here, do not round. I don't know, I was trying to be very clear, don't round. If you round it in Canvas, it will mark it wrong because we're not asking you to, because I'm not putting in all those different possibilities in there. It's too much. So then on Canvas, what you're going to do is you're going to just put in 0.768. I think it was negative, right? You see? Yep, 768, and it was negative. Okay, there we go. So this is what you're going to write. Whether you put the 0 here or not there, that's fine. It's just if you have something like this, either negative 0.768 or negative 0.768, either way is okay. And you do this exact same thing here. So now we're going to try a different scenario. What if x is equal to negative 3.76? Then what do you do? Exact same thing. So this is just going to be 1.23. Everything stays the same except for whatever this x is. So it's going to be negative 3.76. And then we're going to minus 3.72. All right. And again, notice right here, whatever we put in for x, we put in for x here. If there were two x's, like x's in two different places, you put them for all those two different places. Okay, it doesn't even matter. All right. And so you're going to put that into your equation or into your calculator. Let's take a look. So 1.23. Okay, I like to troll the system here. Here we go. I'm just going to copy that out. And instead of, I'm going to just go over here. So instead of 2.4, I'm going to put in negative 3.76. So negative 3. It's going to go over it. So I'm going to just push insert 76. There we go. And it just pushes it right over. Perfect. And what do we get? Negative 8.3448. Okay, and it said don't round, so we're not rounding. So negative 8.3448. Remember that. Let's see if I remember it. Negative 8.3448. Did I get it? I don't know. Yep, there we go. Perfect. Okay, so there we go. That's how you do those kinds of problems. Try it again. So I would hit pause, try number 18, do it by yourself, no cheating, right? And then press play to check, right? And you can just fast forward to the part. You don't need to hear me talk the whole time, unless you want to. I will not look badly on you if you do. All right, so again, so we have a new function now. This is our new function. We're not using the previous function because that talks about that problem. Now with this problem, we're looking at this new function of negative 0.4x plus 5.41. And what if x is equal to negative 0.03? What would it be? So we just plug it in. So here we go. And so now instead of this x, we're going to put in negative 0.03 plus 5.41. Again, put that in your calculator. And honestly, you can do it without the calculator, but it's going to take a while. And this is timed, and you don't have that kind of time unless you want to, if you feel that is like a challenge. So negative 0.4 times negative 0.03. If you want to put parentheses around them, feel free to do that. But the only time that is really important is if you have like exponents. So plus 5.41. Okay, 5.422 is what we have. So we get equals 5.422. So when x is equal to negative 0.03, y is equal to 5.42. 2. Right, 2 2s. Yeah, 2 2s. All right, and do the same thing with this one. Ooh, is this going to be a big number or a small number? I think this is going to be a really negative number because this is going to multiply with a negative number. Yeah, and this is a pretty big, the x is a pretty big number. So let's try this out. So it's negative 0.4 times, so instead of this number, we're going to put in 23.6. Or maybe not, it is being multiplied by 0.4. So that's not going to be that big, I suppose. I have to second guess myself. Okay, so once we do that, we plugged it in. So we're going to go negative 0.4 times 23.6 plus 5.41 equals. Okay, and honestly, if you have one of those calculators that doesn't type it out for you like this, what I would do is this. So I go, remember multiplication goes first. So negative 0.4 times that by 23.6, and you just put equals, and you get negative 9.44, right? And what are we going to do with this? We're going to add 5.41 to it. Oop, just kidding. So plus, it's being difficult. Okay, so when we get this answer, we go plus. So do you see how it includes that? Is ANS just means that previous answer? That should work for yours as well. If you just push plus, it uses the previous answer to add to. right? Plus 5.41. And that's just so that you don't have to keep on doing it. And so do you see, same answer, negative 4.03, which is what we got right there. See? Negative 4.03. Perfect. There we go. All right. So we have we'll have 4 more problems to go. We're almost there. All right. So there are 3 of this type. And you will have to use the equation editor for this one. I know it'll be a little bit difficult. I'm going to write it out first, and then let me see if I can do this on the equation editor, actually. All right. So it says rewrite the explicit formula. So this should look familiar to you. And we're going to write in function form. So what we're going to do is, oh, and then it says, then identify the y-intercept of the function. So make sure you do that part. You got to make sure you read all that stuff. So a sub n, and honestly, if this isn't function notation, we're just going to change it right now. So this is just going to be f of n. So now it's in function notation. And we're going to first distribute this guy. And when we distribute the -2, it is -2 instead of positive. So it's going to be 7 minus 2n, and -2 times 1, -1 is positive 2. Right, this is how you show it step by step. And then there's only just one more step. So f of n is equal to, what is it going to be? So I'm going to write this in slope-intercept form. Remember, my n comes first. So it's going to be -2n. And then my 7 combined like terms, right? 7 plus 2. That's 9. That's it. And I don't know actually if you need to use the equation editor. I guess you could just write it just like this. Okay. Do you need to show these guys? No, you don't need to do that. You can just show me by doing this. And so there, that is it. That's your answer. And it says identify the y-intercept of functions, and you would just say y-intercept is, and you could just shorten it by saying this, the y-int is 9. That guy right there. That's the y-intercept. All right, so how do we do that for the next one? Exact same way. So f of n is equal to, so again, we're going to distribute the 4. So here's the -1 right here, and it's going to be plus 4n minus, well, because 4 times -1 is -4, just like that. And then the next line you would write or type in 4n first, 4n, and -1 minus 4 is going to be -5. Okay, that's your equation. And it says, what is the y-intercept? Y-intercept, oh, I guess instead of is, you could just put equals, right? Is, what is it called? -5. Notice I include in that minus, right? Because think of it as like a plus negative. It's still a negative, okay? That's what that's going to look like. Let's try this again. And I'm going to actually type it this time. So let's try typing it right here. Actually, let me see if I can do it like this. Okay, there we go. There's a couple of steps out there. So again, f of n, and I don't like it when it should not be capitalized, it should be lowercase. So f of n is equal to, and the reason why I use n instead of x is because this variable is an n. So if if the variable that we're using is an n, then whatever is in this parentheses would copy that. If it was a p, then I'd use p, it would be f of p, right? Most common is either the x or the n. Those are the most common. We usually don't do O's because it looks like zeros, so we don't do that. Okay, so we would write -10, and then we're going to distribute the -2 all the way through. Ooh, right. So it'd be -2n. Let me move that away. And then so -2 times -1, which is +2. Just like that. So that's going to be our first line. And then our second line, we're going to be like, okay, f of, when it does that. Okay, I'm not sure if that'll be the same for you. And then what I'm going to write in there, so remember, we're going to write in our slope with the n first, so -2n, and then -10 plus 2, which would be -8. And if you would like to put a little bit of space in there because that's like, too crowded for you, I know sometimes I get like that, maybe like this, that's fine. Either way, if you don't like any space, you like everything like this, that's fine too, right? And this is it. And then all we need to write down is what is a y-intercept? We'll be like y-intercept is the -8. Done. We did it. All right. And the last question here is, what is the domain of the linear functions? Okay, so in linear functions, the domain, remember domain is talking about the values of x. Well, what could x be? If you notice this line, let me get back to my marker here. So if you notice this line is an arrow which indicates that's going forever and ever. So what is the domain? Well, if it goes on forever and ever, that's going to be it's what we call all real numbers, right? And we've said it in class and on tests too. So it's all the way from -infinity x to positive infinity. So so this line goes all the way to the left and all the way to the right, right? It's because of these arrows that go this way and that way. And so then the question is then what is the domain of arithmetic functions? Now the arithmetic one, that is, I'm going to indicate that with, I think that's the lightest pink guy. Oh, maybe this pink, to kind of match this one. So do you see these ones? This is the arithmetic sequence right here, right? So if you notice, like the domain of linear functions, they're all like these decimal points in here. All of these points, all is okay, right? Those are all solutions, right? But for arithmetic sequences, it's just these distinct points, right? For arithmetic, and we usually start with 1 and then go on. So these are discrete numbers. Right, discrete meaning we usually don't do any like fractions, and it can't be all real numbers, right? So discrete means these separate, distinct points. Okay, so in this case, this would be like 1, 2, 3, 4, right? They would be discrete numbers. So usually 1, 2, 3, 4, I'm gonna just put etc. and so on to forever. Are they negative? Usually not, right? Because we usually when we talk about arithmetic ones, it is, we start with the first term, then go into second and third. We don't talk about the negative fourth term, right? We usually don't do that. All right, so that is the domain of linear functions and the domain of arithmetic. Okay, so that's what those are talking about. All right, so please make sure you remember these are the answers. If you find that there might be a mistake in one of them, just let me know, just email me. And yep, all the answers are here at the end. So make sure you do that. This is found on Thursdays, which is which day? January 21, under that tab. Okay, so the PDF is there if you want to print out your own version, or if you want to just see it yourself. Or you can just rewind or just fast forward through the video to see like the different problems. Try to zoom in as much as I can. Good luck, do well. I'll see you later.